fine. Just make sure that you take the pass and write down the time that you leave. We're going to do the practice worksheet and then we're going to take our quiz. So the first question, it's a question that I'm hoping you're going to use the answers to help you find the answer. Working backwards. We have to go through each one of these answer choices and see which one is a factor. Remember, a factor is something that can divide into. So let's start checking. This one looks different, so let's skip that one for now. Let's look at this one. X to the 5th power. They both have an X. We can definitely divide X to the 5th by X to the 5th. Can we divide X to the 4th? We can't pull 5 out of 4. So this one doesn't really work. Do they both have an X? Yeah, that one works. Do they both have at least 4 X's? That one has 5, that one has 4. They both have at least 4 X's. So the one that doesn't look obvious, the first one, and we did this in our notes, that if we were to factor out a GCF, if we factored out X to the 4th and X to the 4th, and you pull it out into the front, and you write down what you have left, 5 minus 4 means you just have 1 X, and anything over itself is 1. These are also factors. So this is a factor as well. So the one that is not a factor is X to the 5th. This is direct from TSI type question, and they put this answer choice in to distract you because it doesn't look like the rest. Don't pick that answer choice. This one, we are combining like terms. So we need to figure out, it looks like we've got 2 X terms. And you can use whatever symbols that you want to connect them. Looks like we've got X terms. And then it looks like we've got constants. So it's helpful to go through and mark up the terms so that you know who goes together. For the X squared terms, and when we add or subtract, we don't do anything to the exponents. We leave them the same. So we have 3x squared and we take away 3x squared. So how many x squares do we have left? We have 3 and we take away 3. Yeah, we don't. Those disappear. All right, so for the x terms, I have 3 and then I take away 2. I have 1x. And then if I have 20, and I just did these, you can kind of mark them off as you go. If I have 20 and then I take away 10, how much do I have? And that's my answer. Do I have to write the 1 in front of the x? No. Next question. So this one gives you, but it looks like this. There's no directions. And that's the way it looks on TSI too. No directions. It gives you this and it wants you to evaluate. So with this type of question, let's check the answers because it's asking this equals one of these. Okay, well, let's test it. So the first one, we could check this by distributing. If we distribute, we get x squared times x. So we have 2 x's and we're adding 1 more. So we get x to the 3rd. And then x squared minus 5 would be minus 5x squared. Oh, looky there. That is our answer, isn't it? Does it match? Yep. That's our answer. Question number 4, it says to distribute. So we're going to distribute that in. What I would like for you to do is to do it on your paper. I'm going to do it up on the board. Let's just test ourselves and see how you do. How did you do? So remember that when you distribute, the numbers multiply. 3 times 2 is 6. X times x squared, you add the exponents. 2 and 1 makes 3. 3 times negative 1, so negative 3. X times x, x squared. 3 times 5 is 15, and then there's just an x, nothing to multiply the x by, so it's just an x. On to the bottom of the page. Question number 5 is one of those ugly looking problems that looks scary, but anytime you have a fraction and it looks like that, we're going to rewrite it. So you just rewrite the top. And then we will rewrite the bottom, and we're splitting the fraction. So we rewrite the bottom, and so everything is divided by 2xy. So we are just splitting the fraction up. Once we split the fraction up, we're going to reduce every single fraction. So the first thing that we can look at is the number parts. 28 divided by 2, what's that? 14, good job. And then let's look at the x's. So we have 4, and so when you're dividing, you subtract. We have 4 and we're taking away 1. We have x to the third. For the y's, we have 4 and we're taking away 1. We also have y to the third. The sign stays the same, so it's adding, so it'll continue to add. 24 divided by 2. 12. So we have 3 x's and we're taking 1 away. So we just have x squared. For the y's, we have 2 and we're taking 1 away. So we just have 1 left. The sign stays the same, it's adding, so we continue to add. 6 divided by 2. 3, good job. 2 minus 1, so we just have x. And then 3 minus 1 means we have 2 y's. That is our answer. So anytime you see those ugly looking fractions, you can take and you're just splitting it up and reducing each one. The next problem, we are multiplying. And so when you multiply fractions, you multiply straight across. So we're going to multiply the top, and then we're going to multiply the bottom, and then we're going to reduce. So multiplying straight across the top, you can multiply the numbers with the numbers. So 3 times 4 is 12. And then there's an a and a b squared. Okay, you still have an a and then a b squared. Along the bottom, I have 2 times 6, so that's 12. And then there's an a and then 2 b's, which b times b is b squared. We can put them in that order. Yeah, so normally what we do is we go through and we reduce each part. And so here, what I notice is that 12 divided by 12, that's 1. A over a, that's 1. B squared over b squared, that's 1. So anything over itself, so the whole numerator divided by the whole denominator is the same. And so we end up with 1. You don't end up with 0. Anything over itself is 1. So technically that's 1 times 1 times 1, which is just 1. On your homework, you had a different one. It was a little bit different and it reduced down to just B. And some of you guys were like, is this right? Can it just be B? Sure. Things can reduce. Everything might reduce to 1 or just most things reduce. It just depends. All right. Before we get started on the back, we have another student supplied brain break. So, would you rather eat only veggies or only junk food for the rest of your life? There's plenty of good vegetables. Carrots are good. I don't know. I didn't make this. Broccoli's good. Asparagus is good.
Just eat. I don't really know. You just gotta specify about it.
You'd rather just die if you had to eat vegetables? Sonia, what about you?
I would rather eat vegetables.
Yeah, I agree. I tend to agree.
I want to die happy. You got all of it, yeah?
It's not worth.
I kind of agree. I just feel like that would not be a good way to go. Haven't y'all ever seen Super Size Me? Where he eats McDonald's for a month and he's just a normal guy and he eats McDonald's for a month and starts getting all these like health problems. Okay, would you rather watch only Marvel or Disney?
Marvel fan, but Disney.
Are they, does Disney own Marvel?
But that's not the same.
I didn't make this would you rather, so I guess maybe like superhero movies versus like princess movies. I'd rather watch Marvel. I like Marvel. I agree. I would be miserable in the cold. No. You keep your opinion. You cannot convince me. I would rather be stuck in the hot than the cold. And people that take ice baths are a special kind of crazy. Like no way. I would rather be hot than cold. Yes. Yes.
Heat stroke.
I hate floating in house.
I would much rather have a heat stroke than die of like hypothermia. No, then it's not gonna be that hot. Like we live in Texas. We can deal. I don't like being cold at all. Makes me cranky. Too hot makes me cranky too, but I would rather be hot than cold. Hands down.
That should be.
Cats versus dogs.
I have a dog. I have cats too. I have cats. A dog.
That should be.
This is sometimes when someone admits to having like 12 cats and I'm just like, oh, anybody got like multiple cats?
I have 2 cats.
Okay, 2's not crazy.
That should be things inside here.
Oh, that's worse. That's weird. No, I like dogs. Dogs all the way. Dogs all the way. I love dogs. Yeah, I know. I love dogs. Cats are evil. They are. You can't even act offended. They are. Yeah. Cats are a-holes. Cats do those things, except for barking.
Cats don't bark. I don't like barking. I don't like moaning. I don't like jumping on me in the door. I don't like it.
Cats can do most of those things. My cat kind of barks. My cat does like. My cat. I'm married into a cat. Well, I would love to be a stay-at-home dog mom. I wouldn't want to be a stay-at-home like mom to the children, but I'd be a stay-at-home dog. I love my dog. Okie dokie, on to the back. And remember that to get full credit for this worksheet, all you gotta do is make sure you're showing your work. And these questions are just like questions from our homework. We have to make sure that we distribute the exponent, and it has to distribute into both the numerator and denominator. So we end up with 3 to the 3rd power and x to the 3rd power. We need to figure out what 3 to the 3rd power is. That is 3 times 3 times 3. Yep, it would be 27. So be careful, it is not 3 times 3, so it's not 9.
Yeah, that'd be ridiculous.
For question 8, see if you can do question 8. I'm going to do it up on the board. I believe in you that you can get the right answer. Did you guys get the right answer? Good. Let's get those right on the quiz. Say that again. It's 7 times 7. The exponent tells you how many times you multiply that number. So it means you have 2 7s. So 7 times 7. Anybody else have a question? Maybe you got a different number? Remember, it's not 7 times 2, it is 7 times 7. It says you've got 2 sevens. Question number 9, it says if a triangle has sides of length 3x, x minus 2, and x plus 5, what's the perimeter of the triangle in terms of x? So what I'd like for you guys to do is draw a triangle. Doesn't really matter what it looks like. We're going to label it. Doesn't really matter where you put the labels. We just need to put all 3 of them. How do we find the perimeter? What is perimeter? You add all the sides. Remember that those x's are like a 1x. So if I add them up, I have 3 and then 2 more x's. So I have 5 total x's. And then I have 5 minus 2. For question number 10, it says if an equilateral, what do y'all think that means? Sides are the same. So you can see equal like inside there. That means that everything's the same. Equilateral triangle has sides of 8x. So you could draw a triangle. Mine's not very equal, but that's okay. So the perimeter of this one, same thing. We've got to add up all the sides. So you've got 8 plus 8 plus 8. Any questions over question 9 and 10? You good? Okay. Any questions? Okay, remember we're gonna quiz today, so if you guys have questions, I'm happy to stop and answer them. The next thing that we're gonna do is review graphing lines. So the first question on the left says, what's the equation of the line below? One way we can figure that out is by figuring out the slope and the y-intercept. So the y-intercept is where I would start. So you gotta go start wherever you cross the y-axis. So the y-intercept is -2. From there, you can figure out the slope. So you got to find another point where you cross exactly. So it looks like you cross exactly at 1, 1. So from your y-intercept to the first point where you kind of cross exactly, then we got to figure how far up and over we go. It looks like we go up 3 and over 1. 3 over 1 is just 3. When we write an equation, we can write it in slope-intercept form. So slope-intercept form is y equals mx plus b, where this is your slope and this is the y-intercept. Oops. Sorry, let me move this. There. We got y equals mx plus b, where m is the slope and b is the y-intercept. So we can write y is equal to my slope, which is 3x. I don't know what happened there. Minus 2. Questions on writing the equation of a line? We got to figure out the slope and the y-intercept. Does the what? What do you mean the 1? Oh, like if you put over 1? He's in ISS. And he's here. Good question. Ty asked if the one matters, like if you write it like that. That's totally fine if you write it like that, no problem. You don't have to, but you can. For the second question, it asks us to graph. To graph, we need to look at the slope and the y-intercept. So the slope is what's attached to the x. It isn't the x, but what's attached. So it's -4/3. That means I'm going to go down 4 and then over 3. And the y-intercept is 2. You have to do the y-intercept first because that's how you find your first point. So I've got to go to 2 and then put a point. And from my y-intercept, I can go down 4 and then over 3 and put another point. I could do that a few more times if possible. And I could use symmetry to help me go the other direction. And then I can connect my dots. Remember that a line has an arrow on both ends. And that is it. So we are